All right, so let's take a look at our simplest cycloalkane, cyclopropane, and analyze what kind of strain it has, right? So cyclopropane, skeletal structure is going to be a triangle. And in this case, these carbons are actually flat and in the same plane as one another. And so since it's a triangle, these are 60 degrees, and that's quite a bit away from 109.5 degrees. So this has a lot of angle strain. So we know that's true. Let's take a look at if it has any other types of strain. So remember, there are hydrogens here. Oh, and one more thing about the angle strain. If you're wondering why this is a bad thing, why it doesn't want to go away from this 109.5 degrees, it's because it's going to have poor sp3 orbital overlap, right? As shown in this diagram right here from your book. Or not. There we go. So you can see in this left one over here, we have this 109.5 degree angle, and we've got a good amount of overlap between these orbitals. Whereas in this bent cyclopropane, we have worse overlap, right? So that's kind of just another picture for angle strain. Anyways, let's take a look at other types of strain. So we've got our I right here, and we're going to take a look at the Newman projection of this carbon-carbon bond right here. And so we've got our carbon in the front. And if we think about it, it's got a hydrogen going to the top right, a hydrogen going to the bottom right, and then a carbon going to the left, right? And then if we think about the carbon in the back, you can see that this right here is wedged, and this is also wedged. And so they are actually eclipsing one another. So we have a hydrogen here, and then this carbon is also bound to this carbon as well, which has also a hydrogen here and a hydrogen here. And so as I stated earlier, right, all of this stuff is eclipsed. And so what we have here is a lot of torsional strain. Not just between those hydrogens, but also in between the hydrogens back here, and then the hydrogens in this carbon as well. Remember, this is torsional strain because hydrogen is small, so technically there's no steric strain. If we replace these with some methyls, then we would have some steric strain. And so because of all of this strain, it makes this a higher energy molecule, and it makes these bonds easier to break. So it's easier to break open this ring. And so we can see that this very simple cyclopropane has a whole lot of strain.